Hello, my name is Daniel Kim, and I'm here to tell you about the 3 types of technology used in ICEMAP. Well, first, let me tell you more about my mega mission, Ice and Soil Moisture Active Passive Satellite Mission, or ICEMAP. It is the fusion and integration of 2 previous missions, SMAP and Operation Icebridge. ICEMAP is the product of the need for the preparation for upcoming climate change, as melting ice sheets and global warming are causing higher sea levels.
Now watch as the Daniel-licus losericus rises from the depths of the sea. This creature's former home has been flooded, higher sea levels causing him to evolve into a fearsome predator. Psych, look at that thing, it looks like a fat octopus. Yeah, you better run away.
While this may be an exaggeration, you can see how this would prove to be a threat, especially to people living in coastal areas or low-lying islands. The overall goal of ICEMAP's mission is to accumulate the most accurate data regarding the freezing and thawing rates of sea ice and ice sheets by measuring Earth's surface and looking at its changes. The first thing we will cover is science instruments, observatories, and sensor systems. I will now go through the description of the Soil Moisture Active Passive Machine. The ICEMAP data will be collected through the use of a radar and radiometer. The utilization of very short radio frequency pulses will detect the amount of moisture in the soil, displaying the changes in soil wetness. The antenna spin speed will reach a final rate of approximately 15 revolutions per minute. The antenna will measure 1,000 km swath of the ground as it flies above the Earth at an altitude of 426 miles or 685 kilometers. This will allow ICEMAP to map the entire polar region of the globe with high-resolution radar data every 2 to 3 days. Multiple polarizations will enable accurate soil moisture estimates to be made with corrections for vegetation, surface roughness, and other factors. The sensitivity of these instruments will provide data that will detect thawing and freezing in the scanned soil by comparing the results with previous years in the mission. We have chosen this technology because it is very reliable and its technological methods are sound. Its precision and accuracy are undeniable and will allow for an all-inclusive look in the Earth's soil surface moisture. Now I'm going to talk about ICEMAP's launch propulsion system. This is an example of a launch vehicle that will be used to send a satellite up into space. The first stage of the launch vehicle contains the rockets and the fuel needed to lift the satellite and launch vehicle off the ground and into the sky. The rockets are very powerful as it needs to lift hundreds of tons. After all the fuel has been used up, the first stage is no longer needed and breaks off and falls to the ground. The launch vehicle operator will ensure the safety of the citizens by making sure it lands in an area where there aren't any people or buildings. The second stage has smaller rockets that will ignite after the first stage has fallen off. Like the first stage, it will break off as soon as all the fuel has been used up. The upper stage of the launch vehicle is connected to the satellite, which is enclosed in a metal shield called a fairing. The fairing protects the satellite while it is being launched and makes it easier for the launch vehicle to travel through the resistance of the Earth's atmosphere. The fairing will split apart once the satellite is above the Earth's atmosphere and will burn up. The rockets of the upper stage fire after the satellite is in space and put the satellite in the exact spot where it is needed. The satellite has now separated from the fairing and the upper stage. Once the satellite reached its desired orbital height, it will unfurl its solar panels and communication antennas, which has been stored away during the flight. The satellite then takes its place in orbit with other satellites and is ready to provide communications to the public. This is the most common form of putting satellites up into space. It is continuously used because it is safe, reliable, and easy to calculate. This is why ICEMAP will be using this technology to put its satellite into space. Hallelujah, 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 hallelujah. Next, we will talk about space power and energy storage. Satellites use panels composed of semiconductor photovoltaic cells, or solar panels as they are usually called. They use the energy inside the sun's radiation, light and ultraviolet rays, into electric power. However, what happens when ICEMAP orbits the Earth and passes through a shadow region on the opposite side of the Earth from the sun? The satellite would be unable to operate and would also freeze to incredibly low temperatures if it not were for some backup power source. The electric energy, therefore, is stored on board the spacecraft when in sunlight for consumption during these eclipses. We will use this technology because it is very reliable and, again, has been used many times previously. It will harness the sun's power, a continuous source of energy, which is very smart as it has no access to other fuel cells or other sources. Now I will cover how technologists collaborate with engineers and trade workers and their role in this mission. Technologists are an important part of the aerospace team. They will work closely with scientists and engineers to support their research. Their skills are used to operate wind tunnels, they work in laboratories, construct test equipment, build models, and support many types of research. In this mission specifically, the technologists will assist in the creation of a radiometer and radar, as well as a rapid pulsing multi-beam approach on the satellite called a laser altimeter. It will give it the ability to estimate the height difference between the polar oceans and the sea ice. The specific types of technologists we need for this mission are aircraft, avionics, electrical, electronics, fabrication, and mechanical. They are all needed to ensure the safety and success of the mission. In this mission, the trade workers and technologists will collaborate to create the satellite and its instruments. The technologists will create blueprints and direct and supervise the trade workers while accepting advice on the safest methods of construction from the head trade workers. Overall, I would like to thank Mr. Bourne for his great supervision, and I had a great time making this video. Thank you for watching, and goodbye.